Hello everyone, in this lecture today we will be talking about DNS or domain name systems. So when we try to access a web page, what we do is we type a URL. For example, you type URLs such as google.com, amazon.com. Now a computer or the network only does not understand URLs. It can only route based on something called IP addresses. And we'll look at IP addresses later in the net when we study the network layer. So, so the human readable names or the URLs are there for for facilitating our understanding, but for the network to operate, we need to translate these domain names to actual IP addresses. So the IP addresses are what is used by the network for addressing, and we need to translate the domain names to different IP addresses. The system that enables us to do this is called a domain name system or DNS. A DNS is, you can think of a DNS as a distributed database and is implemented as a hierarchy of name servers. Now, it's an application layer protocol and it runs at the host. And what it does, it helps translate domain names to IP addresses. An example of a domain name is yahoo.com. It translates something like yahoo.com to an IP address. So this is what is the overview of DNS. So what's the main service that DNS provides? As I just mentioned, DNS translates IP addresses, host names to IP addresses. That's the most important function of DNS. Apart from this, it also provides some aliasing and it helps in load distribution. So what is load distribution? So CNN.com, let's consider a company like CNN.com. It has a number of servers where it hosts its web page. Now, each of these servers is going to have a different IP address. But whenever you try to access CNN.com, you're just typing in CNN.com in your browser. Now, so a CNN.com can actually resolve to multiple IP addresses where the web page of CNN.com is hosted. So why does CNN have multiple IP addresses? This is because it gets a lot of requests during a day, and if it hosts its website only at a single server, the server is going to get overloaded. As a result, it has multiple places or multiple servers where it hosts its web page, and what DNS is going to do is going to map CNN.com to an IP address. So it does it in such a way that the load is distributed among all the servers which are hosting this web page for CNN.com. So it does this load balancing. That's a very important service provided by DNS. I mentioned in the previous slide that DNS is actually a distributed database, and you might be thinking is why we cannot implement it in a centralized manner. The most important thing is that if you try to implement a DNS in a centralized manner, it's going to have a single point of failure. So if it's a centralized system, if that point fails, it means that the entire system crashes. And it's also not, if you have only a single DNS or a centralized system, it's going to be able to handle a lot of traffic, which is pretty hard. That is why we have a distributed structure for the DNS. So the answer is it simply doesn't scale. So here is the structure of the DNS, or it's a distributed hierarchical database. At the very top, there are the root DNS servers, and there's not a single root DNS server. There are multiple root DNS servers. At the next layer, what we have are TLD or top level domain name servers. They are basically the .com, the .org, or the .edu DNS servers. At one level below, we have the authoritative domain name servers, something like yahoo.com, amazon.com. These two are basically connected to the com DNS server. Something like poly.edu, umass.edu are connected to the edu server. So as a first order approximation, when on IP, let's understand how the DNS works. So a client, say, wants to go to yahoo.com. So when it types yahoo.com in the browser, the first thing is or in this example here, it's amazon.com. So when the user wants to go resolve amazon.com to a IP address, what it does, it first contacts the root server to find out where it is, to find out the address of the com DNS server. Now after it gets the address of the com DNS server, it then goes and figures out from the com DNS server the IP address of the Amazon.com DNS server. So this is how the DNS system is used to resolve domain names to IP addresses. Okay, so as I mentioned previously, there is not a single root root name server. There are multiple root name servers. In fact, there are 13 root name servers worldwide. There are a few located in North America, a few in Europe, and a few in Asia. So they are located all over all over the world. So what the root DNS server is going to do is it's going to return the name of the top level domain name servers. Okay, so as I mentioned, what I was just talking about, the top level domain name servers, or the TLDs. They are responsible for com, org, edu, net, and they're also responsible for country level domains like UK, FR, Japan, and so on. Now, these are their companies which actually may provide top level domain name servers. One such company is Network Solutions, which maintains servers for the .com TLD. Similarly, EduCause is another company for the edu TLDs. Now, one level below the TLD servers are the authoritative DNS servers. Now, an authoritative DNS server is owned by the organization themselves. And what it does, it provides a mapping between the IP addresses for the organization and the authoritative host names. Okay, so basically, and something like a company like Yahoo or Amazon is going to maintain an authoritative DNS server to map the IP addresses to the particular domain names. Okay, apart from apart from the top level domain name servers, the top level domain name servers, and the authoritative domain name servers, there's something also, there's some other domain name server, that is a local DNS. The local DNS does not strictly belong to this hierarchy. It is installed by ISPs or companies, or it can even be a university, to to cache some of the local host name to IP address mapping such that this resolution can happen faster. So what happens is, a university or a company has a local name server which caches or keeps a copy of some of the popular host names and the IP addresses. So whenever a host wants to resolve a host name, what it does, it first contacts the local DNS. If the local DNS has a copy of resolving the host name to an IP address, it's going to return that to the host. Otherwise, what it's going to do, it's going to route the query to the router DNS server. Having a local DNS server makes sure that a bunch of requests, or a large fraction of requests, are served by the local DNS itself, and they do not need to be routed to the root DNS server. Okay, so now that we have understood, have a fairly good understanding of what the root DNS is, what the TLD DNS is, and what the authoritative DNS is, and as well as the local DNS server, let's see how domain name resolution actually takes place using an example. So the example that we're going to look at here is the iterated query. So say this host here, that is cis.poly.edu, is requesting is trying to access gaia.cs.umass.edu. To be able to access the web page of gaia.cs.umass.edu, what it needs is it needs the IP address of gaia.cs.umass.edu. So what it does is, first it sends a query to its local DNS server. If the local DNS server has the host name to IP address mapping, it's going to return that back to the requesting host. But let's assume that this DNS, the local DNS, that is dns.poly.edu, does not have that information. In the iterated query example, what it's going to do, it's going to route this request to the root DNS server. The root DNS server is going to provide response back to the local DNS server, that is this DNS server, that's dns.poly.edu, saying, giving it the IP address of the TLD DNS server. Note that the TLD DNS server that it's going to return is basically the edu DNS server. After this, local DNS server is going to contact the TLD DNS server. The TLD DNS server is going to respond, giving it the name of the authoritative DNS server. This authoritative DNS server is the DNS server at UMass, and the name here is dns.cs.umass.edu. What the local DNS server is then going to do is it's going to contact the authoritative DNS server, and the authoritative DNS server is going to respond back to the local DNS server with the IP address of gaia.cs.umass.edu. And then this information is going to be sent back to the requesting host. So this is the iterated query process through which the domain names can be resolved. So we will also look at another way in which domain names can be resolved, and that's a recursive query. So once again, when this host, that is cis.poly.edu, wants to get the IP address of gaia.cs.umass.edu, what it does, it contacts the local DNS server. Assuming that the local DNS server does not have this information, it forwards a request to the root DNS server. But here, instead of sending a response back to the local DNS server, what the root DNS server does is it forwards it to the TLD. The TLD forwards it to the authoritative DNS server, and the information then traces this route back to the local DNS server. The biggest issue with the recursive query model is that the high-level DNS servers, such as the root DNS servers and the TLD DNS servers, have a lot more traffic coming into them. And if you look at the example in the previous slide and this one, you could see that the load at the high level servers almost doubles, or basically the load at the upper levels of hierarchy almost doubles. This is the reason why usually DNS names are resolved using the iterated query approach rather than the recursive query approach. So now that we have an understanding of how DNS records are obtained and what the local DNS server does, let's get into a little more detail as to how the local DNS server keeps records and updates those records. As I mentioned, the local DNS server caches some of the records. Now, whenever it's going to cache some records, there is a possibility that the information that it's going to return to a host requesting to resolve a particular hostname might be stale. To prevent these kind of issues from happening, or in fact to minimize these kind of issues from happening, every time it caches some information, it has a TTL, or a time to live. After the TTL, or this time to live, expires, what's going to happen is this entry is going to be removed from the local DNS server's cache. As a result, whatever information that it caches only stays for a fixed amount of time, after which it's actually removed. In this way, whenever a request is sent to the local DNS server, it tries to give you the latest information and tries to make sure that the information is not stale. So far we have understood how DNS works, and I like to just finish this topic by telling you how records are inserted into a DNS. So for example, you are starting this new company, or you have a new startup, a brilliant idea called Network Utopia. So you are starting this company, you want to register. The first thing that you want to do is you want to create a website. So you buy this, so you want to call the website networkutopia.com. So first what you have to do is you have to register your name at the DNS registrar. So say networkutopia.com is available, so you have to buy this domain name from a DNS registrar. Next, what you have to do is you have to provide the names and the IP addresses of the authoritative name server. Because the authoritative name server, recall that, is only can resolve a domain name to an IP address, or your domain name to an IP address, and this authoritative name server is going to be maintained by yourself. So you have to provide those names to the DNS registrar, and what the registrar is then going to do is it's going to insert these records into the TLD servers, so that once some host requests to go to networkutopia.com, it can be resolved. The root will forward this request to the .com TLD server, and the .com TLD server, because it has this record for networkutopia.com, will forward it to the authoritative DNS server for the networkutopia.com, that is DNS1, say networkutopia.com, and this authoritative DNS server, that is DNS1.networkutopia.com, is going to then resolve it to the particular IP address. The IP address in this case that you've chosen is 212.212.212.1. Okay, with this we will end our discussion on DNS. Thank you all.